Sustainability Science. My name is Stephanie Shu, and I'm an actor. I'm in a Broadway musical called Be More Chill, and I am here to join y'all today to hear about your presentations and what you've been researching in your classrooms, and I am so excited. I got to visit PS 199 on Friday, and it's so exciting what y'all are doing!
Here's the fruit. So thermotherapy is a process where you put the fruit in hot water to prevent the growth of mold and increase the shelf life. So for my experiment, I did 4 groups. The control group, which here are the green ones, they had no thermotherapy. Group 1, they had 35-degree water for 30 seconds, and that group is the brown ones. Group 2 was in 45-degree water for 30 seconds, and those are the reddish or pink paper. And group 3 was in 60-degree water for 30 seconds. And as you see, that's day 1, over here is day 8. So again, that's day 1, this is day 8. The greens are control, the browns are group 1, the reds is group 2, and the orange is group 3. As you see on day 1, all the strawberries were really nice. They look shiny and healthy and good to eat. On day 8, most of the strawberries weren't doing so good. These strawberries that have prickly seeds, the strawberry over there has a lot of bruises and it looks mushy. But if you notice, the orange strawberry on day 8 looks a lot better than the other 3. So, because for my experiment I had to interpret visual data, to interpret this data, I made stages of strawberry decay so that I could put them into what stage they fell into. So in stage 1, the strawberries are beautiful, they have bright red color, they're shiny, they're firm, and in stage 2, there's some small bruises, like soft spots, so the strawberries are shiny and firm. In day 3, the strawberries are darker by the tip, they're a little softer, they're more neutral, and the leaves start to shrivel up. By stage 4, the strawberry is covered in bruises, they're mushy, has very bruised tip, the color is dark red now, and it's very neutral, has a neutral firmness by the leaves, and very soft tip. On day 5, on stage 5, the strawberries will look good enough to eat. It's mainly bruised, it's soft, it doesn't look edible at all. I wouldn't want to eat the strawberry. So these are my results. So the y-axis are the stages, and these are the groups, and the colors are the days. If you can see, there's group 1 and the control group are very similar, decay at a very similar rate. Turn to group 2 did a lot better, getting a little slower. Turn to group 3 has the biggest change. It actually didn't reach stage 5 by day 8. So, in conclusion, thermotherapy did prolong the shelf life of strawberries. The higher the temperature, the slower the rate of the strawberries decay. Perhaps you could try higher temperatures. This is very important because, especially now, fruits are imported from long distances, especially in the winter, because strawberries grow in warm climates, so during the winter, they come from other places. And because they're imported, some places don't have a lot of access to fresh fruit, because fruit spoil. So thermotherapy can be a way that we can get other places We have access to fresh fruit, which are really important in our diet. We have vitamin C and foliate and potassium antioxidants. So yeah, thermotherapy shows a great potential in doing all of this.
Saviour High School. And I did a project using something that I think is really cool, which is magnets. Before I started my project, I had to answer a lot of different questions. And the first question I had to answer is, what kind of plant am I going to use in my experiment? So I actually decided to use wheatgrass. You might not have heard of that plant, but a lot of people use it for shakes and smoothies and drinks, for health drinks, because it has a lot of really good benefits. It's very easy to grow. You can grow it almost anywhere. It grows to full size in almost 6 to 10 days, and it does a lot of really cool things. It helps prevent diabetes, it treats stomach issues, it provides many vitamins and antioxidants, and it also contains high amounts of protein and fiber. So this is definitely a plant that you want to have around. And my next question I had to answer was, what kind of magnets am I going to use in my experiment? The idea that I had before starting this was that if I exposed plants to magnets, they would grow better. So I had to pick really good magnets to make sure that it would work. So I had three different groups. My first group was my control group, where it was just plain plants, no magnets involved. The second group was my first control group with the weak magnet over there on the left, and the other one was the strong magnet over here. But a problem that I had that I didn't really realize would happen was rust. If you put metal in water for a really long time, it gets really rusty and gross. And that was not good because it interfered with how the plants were growing. So for my next trial, I got even better magnets. For my wheat group, I got magnets that were made of iron, but they had this special plastic coating on them that made it so that they wouldn't rust. And for my second experimental group, I had these super strong magnets. They're made of this material called neodymium, and they're so strong that they can actually stick to the hood of a car. And the rust was totally gone. I didn't have that problem anymore. So all throughout the experiment, I had to take a bunch of different measurements. So, of course, I measured how tall the plants were growing to see if the magnets changed that. But I also had to measure the pH, the temperature, and the electrical conductivity of the water. This was all to make sure that the plants were getting enough nutrients and that they were going to be okay while they were growing. And I used a bunch of different tools to do this. I used a ruler to measure the height. I used a pH pen and an EC pen to measure the water. And I also had this special little solution that I would pour in, which had MaxiGrow, which is full of nutrients, and water. And that would make it so that the plants could grow right. And I put all that in using a measuring cup. So here's a picture of how I set my experiment up. All the way in the back is the control group with no magnet. You can see I have 2 sets of Rockwell squares there. There's 8 in each group. In the middle, I have the experimental group number 1. Now, you can't really see it that well here, but the weak magnet is in the middle between those 2. And in the front, you have the experimental group 2 with the strong magnet, and that magnet's sitting right there in the middle. And I drew a little picture so you can understand how I did it better. So you can see all the way on that end, you have the control group, there's nothing in the middle. In the middle, you have the experimental group 1 with the weak magnet in the middle there. And over here, experimental group 2 with the strong magnet in the middle. So after a really long time, this took me almost a month and a half, I put all of my data together and I came up with a couple of graphs. So I found out that if you have no magnet, the plants actually grow taller. And that doesn't seem like it really makes any sense. But I also did something else. I weighed every single plant that I grew. And I found out that the stronger the magnet, the more the plant weighs. So I was pretty stumped when I figured this out. But I did a lot of research, and here's what I think happened. So I found out that by exposing water to magnets, the salt ions change and dissolve, creating pure water
that is more easily taken up by the plant. So right here, I kind of have a little map that shows my way of thinking. So if the water given to plants is exposed to a bunch of different magnets, then that means that the plants take up more nutrient-rich water than the other plants that have no magnets. And then that means that there's more growth inside and not outside, but the height is smaller. So basically what I think happened is the plant cell size went down, but the cell density went up. Density is really like how much stuff is inside of something. It's not necessarily bigger, but you can usually tell by how much it weighs. So I think that because the plants with magnets were heavier, they were actually denser, which means they had more nutrients. So when I finished all of this, I really have to think, how can I make this better? If I want to do this experiment again, how can I make it better? So what I realized was I had all of the plants sitting in one tray in the same water. But if I really want to see how magnets change the plant growth, next time I'm going to have to separate the water that the plant's growing. That could change so many things. That could change the height, the weight, and it could change the electrical conductivity of the water, which is usually just used to measure the nutrients, but maybe the magnets could change that too, and that would have an impact on how plants grow. So I have a little picture here, and I want you to think about something. You see all of these carrots? Do you want the skinny ones, or do you want the fat ones? The skinny ones have taller leaves on top, and the fat ones have much smaller leaves. But even though from the top, that one looks smaller, it's actually better on the inside, on the bottom. So what I figured out is quality is better than quantity, and that means that you want something to be good. You don't just want to have a lot of it. Urban farmers, all of us growing plants in the city, we need a way to grow richer, more nutritious food in a really tiny amount of space, because we don't have huge amounts of grasslands where we can grow crops. We have schools and office buildings, and not a lot of room. So we're going to need a way where we can grow the best food we can, even if it's not going to take up that much space. So my last thought is, how could this help people globally? So climate change, that's what we've been talking about all day. Climate change does a lot, but one main thing that it does is it creates really bad weather. People don't know what the weather's going to be, and sometimes the weather really wrecks a lot of plants and a lot of crops, and it's very, very bad. So what we need is a new way to grow plants. So if I do more trials with these magnets, if they actually make plants grow better, then maybe that can help us fix our problem of plants that are not growing well due to climate change. Thank you.
Saviour High School, and I wrote a poem called Hope for Our Planet. I believe there is hope for our planet. Times are changing. People are believing in the possibility of a clean earth. Solutions are springing up to multitudes of problems, like the greenhouse in my school. We grow cucumbers and eggplants and peppers and kale, and mountains more, in a brownstone that is over 100 years old. It's absolutely incredible, and most importantly, edible, and it's all 100% delicious. People are discovering new miracles daily, and technology is changing to provide fresh food to people who are not able to access it, and making it easier to grow nutritious food indoors so the land can be used to shelter others. We might be in trouble, but you can ask any person on the planet, no matter their race, religion, or creed. If you ask them what they believe, they will reply, I believe there is hope for our planet. Thank you.